Hello again. This is the course of data structure and algorithms. I'm going to explain about the next data structure, which is related to list. And the data structure name, we call it as linked list. This lecture also taken from the book of data structures and algorithms in Python from Goodrich, Tamasya, and Kunwozer. So let's learn about what is linked list and what are the applications. We already learned about stack. We already learned about queue, and yeah, those two kind of data structure can be combined with the linked list. So we will see what can we do with those things. So the basic definition of the linked list. So you know ADT, okay? So the ADT means this is abstract data type, and we are going to learn about the linked list abstract data type. Let's suppose we have these figures. Okay, so I will use these figures. Maybe it's not that good resolution, but yeah, it will help you to understand what is singly linked list. Yeah. So there are several types of linked list, but for the first time I will just explain about the singly linked list, and next we will learn about the doubly linked list, and you can see some of the implementation with the circular linked list later. A singly linked list. What is singly linked list? So we call it singly because we're having single. Okay? So the single means it is a concrete data structure consisting of a sequence of nodes starting from a head pointer. Okay? What is the meaning by head pointer? So we have this head. You see this one. Okay? This one is the head. Okay? Yeah, we have the sequence starting from the head, and it goes to the last element. Yeah, and this collection of nodes that collectively form a linear sequence. So when we have the linear sequence, means this is sequence from A, and then B, and then C, and then D. And for every uh, place here, we call it, this is a node. Okay? So a node, okay, this is a node. A node consists of element and link to the next node. Okay, let's say I have the element A. Okay, and after the element A, it will connect to element B. After we have the element B, there is a connector to the element C, and after element C, there is a connector to element D. In this case, I know that the element D is the last one, so the next element will be empty. Okay. Now, what is the application of singly linked list? We can see some direct application like routing sequence. So if you go to one place to another place, it means you know what is the next node, what is the next node, what is the next. So it is a kind of routing sequence. And you can also do with delete and undo operations in, for example, Notepad or Hangul or Microsoft Word. Yeah, everything which is related with Office application. So this kind of delete and undo operation, it can be related with singly linked list because it's related with the sequence. What did you do, and then what will you do next? If you want to undo it, then you will go to the previous one. So there should be a connection between what did you do the first one and what you're just doing now. And yeah, for the viewer or like a song, you want to listen to the song and it's based on random, and you want to know what is the next and what is the previous. So those kind of direct application, you can just use very simple single English. In direct application, yeah, it is a kind of auxiliary data structure for algorithms like, yeah, for list, stack, queue, arrays, and etc. And it is a component of other data structures. We may have questions like, why do we need to have the single list? We can just use like array, or we can just use like list in the Python. But of course, when we use those data structure, it is only related with the index, but there is no correlation with the next node. Yeah? This is the basic idea. When we have the list, we will deal with node. Okay? So what is node? Okay, in this case, we have the public class node. Okay? So this class is having two instance, or we call it, this is the data member. If you still remember when we deal with the object oriented. Okay? So the first uh, data member is the object. What is the element of that particular node? And we have another data member which is next. So what is the next object after the current object? So when we are having a node, okay, this is the constructor. Okay, yeah, on this one, we will construct one object, and the object will have null comma null. So it means it is a new node, but there is no object and there is no next node. If you make another object, okay, we can construct with this constructor, and this object will have one element. Let's say the element can be anything. Let's say in the previous example, it's A, B, and C, and D. So the element is E, and then the next node will be, yeah, the N. Okay. So we will have N as the node, so it is related with the class node. So the accessor method, you can have the get element, and yeah, well, I want to know what is the element of the particular node. And then if I want to get the next node, then I can just have the node and then the get next, and it will return the next one. And if you want to change the element, then you can just set the element and give one parameter, what is the new element for that particular node. And then you can also set what is the next item, or what is the next element after the current element. So those are the basic methods in the node for the list, for the singly linked list. Actually, yeah, it is not for singly linked list, but it's also available for the doubly linked list. But this is the basic methods for the list nodes. Now, when we have the singly linked list, we, as I explained before, we have head. Okay? So what is head? So head is the element in front. If you still remember in the queue, it is the data structure with the concept of first in, first out. So what is the element in the first? It will be first serve, and then it will go to the server as the first time, and then after they finish the service, then it will go out. So it's the same with the list or the linked list. Here we have head. So head is the front. Okay? So head is the front. Whenever we have a new element, okay? So yeah, we will okay, let's have the insertion at the head. Okay? If we have the insertion at the head, it means we want to allocate a new node and then insert a new element, and we have a new node point to the whole head, and update head to point the new node. So when we have one element in front, then we can say it is head. If we want to add one more element in front, then we will just give one more node. Let's say this one is Baltimore, and the node that we already have are Rome, Seattle, and Toronto. So we want to set Baltimore before we go to Rome, and this head as the first node will be removed into the Baltimore as the first node. Okay. So the role of the first node will be replaced by Baltimore, and the next node will be room, and then it will be located in the element, sorry, in the variable next. So this one, it seems that we can know that the head is now Baltimore, and then what we will go to the next is Rome, and we will go to the next is Seattle, and we will go to the next is Toronto, and then finish. So this kind of sequence is common when you want to do like a travel, or you want to have a trip. There's another kind of operation, for example, removing. Okay, so you want to remove the head. Let's say, yeah, in order to remove the head, you need to update the head to point to the next node. So if you have this head, yeah, and then let's say I want to delete. Okay, I want to cancel my trip to Baltimore, so I just want to go directly to Rome. Okay? Then, yeah, you first need to go to the next item or the next element. The next element is Rome, and after you have the new head, this is the element of Rome, then you can just remove it. Okay? And it allows garbage collector to reclaim the former first node. So this will be going to go to the garbage collector. So the garbage collector is a kind of uh, method, or it is a place to save all the data that you want to delete. Okay? And after you put this in the garbage collector, then you have the new head with this Rome. And yeah, this is the single list. We have Rome, Seattle, and Toronto. So it is about the head, yeah? And everything you can consider whether you want to insert in the head or you want to insert in the last element. It's also the same. And let's say if you want to insert in the last element, what is the last element? We call the last element as a tail. So if it is a tail, it means the next element is empty. So there is no element in the next one. Then if you have an element in the last one, then you can just insert a new element. Okay? So allocate a new node to make a new node, and then insert a new element. And after you insert a new element, let's have a new node point to null. Okay. So what does it mean by this one? We have null. Null. This one is null. So we want to point this node. This is the new node. Okay. When we have this new node, we want to have the next point into null. Okay, so this is also null. Okay, when we have this node and we have the next node is null, then have the old last node point to the new node. So we will update this link into the current node. Okay, then after we have the link to the last node, and then don't forget to update the tail to point to the new node. So when you have a new linked list, then you will have the new tail with this one. So the head is Rome, Seattle, Toronto, and I will go to Zurich, for example, because it is a new node. If you want to remove the tail, okay, what is the way to remove the tail? Removing at the tail of a single linked list is not efficient. Okay. What does it mean? Yeah, if we want to remove the tail, it means we want to there is no constant time way to update the tail to point to the previous node. So if I want to remove this tail, there is no constant time because I need to go to the head, and then I will go to the next, and then I will go to the next, I will go to the next, and then after I know that it is the tail, then I will remove it. And yeah, there is no such constant time. So why we didn't want to consider the constant time? Okay? Because it is the most efficient way. Okay? This is the lowest algorithm analysis function that you want to use. Yeah, many algorithms consider like ON or O log n. Yet of course, using the n is good, but if you can use a constant way, then that will be much better. So if we already learn the basic idea about insert in the head, remove on the head, yeah, it will be efficient because it is just constant. If you want to insert into the tail, it is also constant. But if you want to use the remove function on tail, then there will be some, yeah, time to remove this one. It's not a constant time. In order to use the constant time for this tail, yeah, there will be another uh, linked list for this issue. So I just want to consider that when you are doing with the linked list, yeah, there's the concept of the linked list before. We can apply some other data structure, for example, stack. Okay? If you are doing with stack, then you can try to figure out what is the best way to remove. So, for example, this one, if we have the stack with the single linked list, we can say that the top element is stored at the first node of the list. Okay, so if you still remember when you use the stack, okay, let's say this is the stack. Yeah, we have the first element, and then we have the next element, and we have the next element, and then we have the next element. Okay, after we have this, yeah, then we can say that this is the first node, or this is the head. Okay, if we are telling that this is the head, yeah, then if you want to remove the tail, what happened? Yeah, that will be uh, it. There will be some time to figure out how to go from the first until the tail, and then if we want to remove, then it means we need to do on. Okay. If we have this stack operation for uh, the if you still remember, okay, stack ADT, if you're doing the insert and if you remove more one element, then it will take O1 time, so it's constant. Okay. If you want to use the removing tail with the uh, Q, okay, that's also can be regarded with O1. Okay. So when we have the linked list, one of the things we can implement with stack. Okay, when you implement with stack, it will take the O1 time. So this is the linked list stack in Python. Okay. So let's say we have the node, we can create the node, and then after you have the node, we want to create the stack methods. The stack method consists of the constructor, and then it will check the length, and then there's is empty, push, and pop. Okay, you can figure out this one. Okay, pop. Then yeah, it means everything in the stack is available in the link stack. The difference is only we have one more class which is related to node. Okay, so we will see the one code related with the linked list stack in Python. The other way to deal with the linked list, you can use the queue as linked list, and you know that the queue is using the concept of first come first serve. So we can implement a queue in the single linked list. The front element is stored as the first node, and the rear element is stored at the last node. So if you're having problem with the head and tail issues like what we already saw before, so the last or the tail, if you want to remove the tail, if we just use the concept of stack, maybe it will run on time. But if you want to use the queue, it might be different. Okay, so the space used with the linked list is on, and each operation of the QADT will take O1 time. So you know the operation for the stack and the queue are the same. So we have insertion, we have deletion. So those two operations are common in every data structure. So in the future, you will also know that those operations will be available. adding or insertion and removing. The same with the stack, the operation is taking one. So for example, this one, yeah, we have the f is the front, okay, and the front, and then r is the rear. Okay. When we have the q, so the q is something like this one, okay. If we have this element as the first and the second element and the second, and the next element is the third and the next element is fourth. So if we take q, then the first element will remove, okay. After this element is removed, then yeah, if the element is removed, then the next element will be the first, and so on. So we can do with this kind of mechanism for the linked list. And this is the linked list queue in Python. So the idea is also the same if you are doing with the link queue. Okay, you have the node. Okay, node is representing the linked list that we already saw before in the first time. And then we have the init, this is a constructor, and then we have the length, we have this empty, we have first, and then we have the queue, and we have enqueue. So the idea is the same with the queue, but the new thing here is we are adding the class node. Okay, so let's see if I want to check the code. Okay, so I already give you the code here. This is from the book that we use. For this code, I will use one Python file which is exceptions. Okay, so there's an exception.py. If you open this one, it is one exception that contains one statement which is pass. So it means if there is an empty element, then you will go to this exception and you can just go to the next one. So I am in this example, I will not give you more the example how to use the link stack or the link queue, but maybe after we learn all the things about the link list, I will give you one example how to use this data structure in a particular application. So in the link stack, yeah, in the link stack, you know the stack is last in, first out. So yeah, I can say this is Livo. Okay, and when we are using the link with stack, there is one more class that you not consider with this node. And these nodes you already learned before. We have the element and we have the next. So it means this node has one element and we want to know what is the next element, which is the also related with node. So element is the element and next is reference to the next node. And we can have the stack methods as the what we already learned before. So it is about the constructor, the length is empty, and then we want to push. So push means I want to add one element. Top, I want to check what is the element in the front, and then pop. Okay, I want to move or I want to remove the element at the top. So those rays, okay, if you still remember this exception, okay. So now I'm going to use one exception from the given from the author of the book. It called empty. So if it is empty, then you can just you can just print stack is empty. If it is empty, stack is empty. Okay. The other, this is the first. Uh, this is about the link stack, and the other is about the link queue. Okay. So link queue, as you already see the code in the PPD, this also representing that one. We can use the exception. If there is an empty element, then it goes to error. So in order to avoid those kind of errors, we can just use the exception and then we will print the exception. The same with the stack. It has the class node and it has the element and next. Okay? And then we want to create the object of the queue. And we have the constructor. We can check the length. We can see one method which is empty, whether the queue is empty or not. And then we want to know what is the first element, and then we can do the dequeue. It means we want to remove the element, and then we have enqueue. We want to insert a new element into the queue. Okay. So yeah, that's about the single linked list, and I will continue with the doubly linked list on the next video. And I hope you can just think this very simple. Don't be uh, so worry with the idea of linked list. Maybe you will have a question: what is the difference with lists actually? Yeah, there might be some application that you can see about the linked list and list, and we will check more with the other videos about this issue. So please keep monitoring with the new video, and if you need more practice or if you need more idea about the use of this data structure, I will keep posting on the Facebook, so you can try to figure out what kind of problems that you may have in your exam. Okay, thank you very much for listening. See you on the next video.